Today I'll be reading a portion from Chasing the Sun, the epic story of the star that gives us life by Richard Cohen. It's chapter 12. The name of the chapter is The Sun Dethroned. Quote, Grandmaster, oh, if you knew what our astrologers say of the coming age and of our age, that has in it more history within 100 years than all the world had in 4,000 years before. By Tommaso Campanella, born 1568 and died 1639. The City of the Sun. Quote, I am greatly relieved that the universe is finally explainable. I was beginning to think it was me. By Woody Allen. The main text. The sun does not stand still or even move in a simple pattern. At different times and under different examinations, it may appear a solid orb, a ball of fire, or a constantly discharging source of winds, flares, spirals, and radioactive particles. Its latitude rotates at different speeds, and its whole surface surges up and down about 2.5 miles every 160 minutes, although even to talk about the sun's surface is misleading, since, being largely a collection of gases, it has none. Seen from other planets, it's larger or smaller than when viewed from Earth, and its atmospheric effects are different on Mercury, say, than on the torrid mists of Venus. And different again on our planet. By the end of the 18th century, astronomers had recognized that it was simply one star among many, just the one that happened to be nearest to us, and had estimated its distance, size, mass, rate of rotation, and movements in space to within 10% of today's values. But they continue to gnaw away at other problems. What was going on inside it? What caused it to shine? How old was it? And how did it relate to other heavenly bodies? Only now were they finding many of the answers. Between 1800 and 1950, aided and abetted by advances in technology, the Industrial Revolution, and a new enthusiasm for scientific inquiry, hardly a year went by without astronomers, physicists, chemists, and geologists finding something that added to our understanding. In just the first half of the 19th century, for example, absorption lines in the solar spectrum were mapped, and electromagnetic induction and electromagnetic balance were being discovered, both of which increased our knowledge of how the sun draws us to it. During the same period, the sun's energy output, the solar constant, was measured, leading to a greater appreciation of both its temperature and its influence on climate. In 1860, the corona and In 1860, the Vatican's chief astronomer photographed the eclipse of July 18, showing that the corona and prominences were real features, not optical illusions or deceivingly illuminated mountains on the eclipsing moon. The list of specific discoveries runs close to 200 in just a single decade, 1871 to 80. For instance, came electromagnetic radiation, the solar distillation of water, the sun as purifier, and the first radical re-estimate of the sun's age at 20 million years and of the length of time it would have taken to contract to its current size, both of which were to touch off a major debate between scientists and literal interpreters of the Bible. Other discoveries were less contentious. The sun's surface temperature was estimated at 9.806 Fahrenheit, that's 5.430 Celsius, while its core was reckoned to be gaseous, with temperature steadily decreasing from its center to the surface. Several new instruments, the heliospectroscope, star spectroscope, telespectroscope, were invented, and all fixed stars were found to display only a combinations of spectra, depending on their physical, chemical nature, an achievement of as great significance as Newton's law of gravitation. In recent years, writers such as Dava Sobel, Timothy Ferris, and Bill Bryson, as well as popularizing scientists including Carl Sagan and Stephen Hawking, have demystified such esoteric subjects as dark matter, its invisible but still exercising attraction whose presence we infer from its gravitational pull, though we don't know what it is, and black holes that's familiar but still difficult fully to imagine. But what about deuterium, the ionosphere, even the Coriolis effect? Such words and phrases are part of a discourse that can seem close to most of us. But 2 or 3 of the main strands of research can be braided together to show how, between 1800 and 1953, our knowledge of and our feelings about the sun were transformed. Toward the middle of the 19th century, the French philosopher Auguste Comte was asked what would be forever impossible. He looked up at the stars. We may determine their forms, their distances, their bulk, their motions, but we can never know anything of their chemical or mineralogical structure, and much less that of organized beings living on their surface. Within a surprisingly few years, mankind would have grasped those very truths. To put into context how quickly research expanded and focus shifted, in 1800 only one stellar catalogue of precision was available in 1801. J.J. Lalande published one describing 47,390 stars, and in 1814 Giuseppe Piazzi added another 7,600. Others followed between 1852 and 1859. Alone, some 324,000 were registered. Photographic charting began in 1885, and by 1900 the third and concluding volume of a work appeared that located a massive 450,000 stars, the fruit of collaboration between scientists in Groningen and John Herschel in Cape Town. It became abundantly clear that the sun did not hang there as the supreme object, but was just one more star, an unspectacular one at that. Scientists could now concern themselves with this multitude of other suns, many far larger and heavier than our own. There's a footnote, beginning of the footnote. In the first quarter of the 19th century, a German astronomer formulated Olber's paradox. Were there to be an infinite number of stars in the universe, there would be no night. The sky would be one huge glare, and we would be drowned in, indeed could not have come into existence under such overwhelming stellar energy. A good explanation of why this is not so is worked out by 15-year-old Christopher Boone, the autistic narrator of Mark Haddon's 2003 novel, The Curious Incident of the Dog in the Nighttime. I thought about how for a long time scientists were puzzled by the fact that the sky is dark at night, even though there are billions of stars in the universe and there must be stars in every direction you look, so that the sky should be full of starlight because there is very little in the way to stop the light reaching Earth. Then they worked out that the universe was expanding, that the stars were all rushing away from one another after the Big Bang, and the further the stars were away from us, the faster they were moving, some of them nearly as fast as the speed of light, which was why their light never reached us. One should further add that no star shines for more than 11 billion years. Another footnote, certain objects have the letter M before their designated numbers in honor of Charles Messier, the French astronomer who in the year 1774 published a catalogue of 45 deep sky sightings such as nebulae and star clusters. The final version of the catalogue was published in 1781, by which time the list had grown to 103. Back to the main text. Even this piece of knowledge was to be massively augmented. In the pre-dawn hours of October 6, 1923, at the Mount Wilson Observatory, Edwin Hubble was examining a photograph of a fuzzy, spiral-shaped swarm of stars known as M31 or Andromeda, which was assumed to be part of the Milky Way, when he noticed a star that waxed and waned with clockwork regularity. The longer it took to vary, the greater its intrinsic brightness. Hubble sat down and calculated that the star was over 900,000 light years away, 3 times the then estimated diameter of the entire universe. As National Geographic reported the story, clearly this clump of stars resided far beyond the confines of the Milky Way. But if Andromeda were a separate galaxy, then maybe many of the nebulae in the sky were galaxies as well. The known universe suddenly ballooned in size. Today we know that there are at least 100 billion galaxies, each one harboring a similarly enormous number of stars.